Cartesian coordinate plane. This is very heavily focused on in algebra class, and for good reason. It's very useful. And we're going to plot some ordered pairs and then start to look at some properties of ordered pairs or points on the graph. So we have Cartesian coordinate plane. So Cartesian coordinates, you have an x-axis and a y-axis. And Cartesian coordinates are written x, y. X is how much to go to the right, y is how much to go up. And if they're negative, instead of going that many to the right, you will go negative that many, which means you're going to go to the left. Same thing with the y-coordinate. If the y-coordinate is negative, you're going to go negative units up, which really means you're going to go downwards. So we'll plot a couple points. 3, 4, over 3, up 4. Here's a good time to talk about handwriting in math. You don't want your 4s to turn into y's or your y's to turn into 4s. You're going to notice mine are pretty close. I try to keep my 4s pointy, and my y's tend to get a little pointy sometimes too. They also look like 7s. So just be aware in math, you don't have the benefit of context, because a lot of times a 4 could exactly equal y and you could be swapping them. So you want to be careful that your 4s look like y's, and there's other letters too you need to be careful about. So over 3, up 4, all we do, put a point there. So that's Cartesian coordinates. If they're negative, we're going to go to the left or down, depending on if it's negative x or negative y, respectively. Now there's another example in the textbook. Strongly recommend you follow along with the example and graph those points. Quadrants. So quadrants are, well, quad, 4, so there's 4 of them. There are 4 ways, 4 places here. And they're labeled in a little bit strange way. We have quadrant 1, quadrant 2, quadrant 3, and quadrant IV, quadrant 4. Roman numerals are annoying, so I recommend you just go 1, 2, 3, 4. So quadrants like this. Why are they labeled like this? We start at the positive x-axis. As to why do they go counterclockwise, you have to wait till trigonometry. Well, basically, you want your first quadrant to be where everything is positive. And that's why we go quadrant 1 is where everything is positive. And you kind of think of it as getting more negative, less negative. So what happens over here in quadrant 2, you have negative x, positive y. Quadrant 3, everybody's negative. Quadrant 4, positive x, negative y. And then back to quadrant 1 where everybody is positive. So these are the signs of the 4 quadrants. So if you're plotting a point and you know it's positive, negative, you know it will be positive, negative. It'll be in quadrant 4. Now we have points. They can be symmetric. What does symmetry mean? It means that if you reflect it across one of the axes, you could either go across the y-axis or across the x-axis, you get the same image. Another way to think about this, if you don't like to think about mirrors, you could think about if you're cooking something over a fire, you're going to rotate it. When you rotate it exactly halfway, if it looks the same, it has symmetry. So we'll just use the same point, 3. I should probably try to make this accurate. 3, 4. All right. So which point on the graph does this have symmetry with respect to the y-axis? So here again, my 4 looks like my y. So there's my y-axis, x-axis. I want symmetry with respect to the y-axis, so when I flip it over or rotate it halfway around the y-axis, my point will be over here. So here's my symmetric point. So symmetric with which point with respect to the y-axis? We drew it here. All we have to do, what's the difference between these 2 points? They both have 4 as their y-coordinate. So we can fill that in. Now x-coordinate, instead of positive 3, negative 3. So we went from quadrant 1 to 2, and all that happened was our x-coordinate became negative. So there's symmetry. You could have the same symmetry going across the x-axis. And what would that be? It would be this point down here where your y-coordinate would flip to negative. So if you want symmetry with respect to the x-axis, you take your y-coordinate, make it negative, you're down here. You could have symmetry with respect to the origin, which means if you reflected it twice, you would be down here. Now that's a little bit tricky to think about. An easier way to think about it, rotate it around the origin. So if you rotate halfway around the origin here, where will you be? Right here. What coordinates do we have? Well, instead of positive 3, positive 4, we're going to go left 3, down 4. So origin symmetry. You have xy is going to be, if you swap your sign on x and y, you will have origin symmetry. So there's origin symmetry. What happened over here? We had y-axis symmetry. So if we swap out our x-coordinate for negative x, we get y-axis symmetry. And x-axis symmetry, you take your point and bring it across the x-axis. That makes the y-coordinate negative. And there is symmetry.